Most machines have one life. They are built, they work, they wear out, and they disappear into the anonymous silence of the scrapyard without ceremony or memory. The history of industry is largely a history of that cycle, repeated millions of times across every era of mechanical civilization. But every once in a while, a machine refuses that cycle. Not because anyone planned for it to refuse, not because it was specially preserved or carefully protected or held back from the grinding demands of actual service, but because something in its construction, something in the combination of materials and design and sheer mechanical stubbornness made it capable of surviving things that should have ended it over and over again, across distances and decades that no machine was ever designed to endure. This is the story of one of those machines. A locomotive that was officially declared unserviceable 6 separate times across 3 continents, that was abandoned in a South American jungle, sold for scrap in South Africa, bombed in North Africa, and left to rust on an Australian plain, and that somehow, through a combination of extraordinary engineering and extraordinary luck, survived every single one of those endings to run again. You need to understand what the world of railway engineering looked like in the 1890s to understand why this machine was built the way it was. Because the qualities that would eventually allow it to survive everything history threw at it were not accidental. They were the direct result of a design philosophy that was considered, in its own time, to be extreme to the point of irresponsibility. The man responsible was a Scottish engineer named James McAllister Graig, who had spent the first 15 years of his career working on locomotives in the most demanding conditions that the British Empire had to offer. He had worked in India, where the combination of extreme heat, poor water quality, and inadequate maintenance facilities destroyed conventional locomotives at a rate that dismayed railway companies and enriched the manufacturers who supplied replacements. He had worked in South Africa, where the distances between workshops were so vast that a locomotive that needed specialized attention often had to travel further to get that attention than it had originally been built to travel. And he had worked briefly in South America, where conditions combined the worst elements of both previous experiences and added tropical humidity and river crossings that would have seemed like engineering fiction to anyone who hadn't experienced them personally. What Graig concluded from these experiences was a philosophy of locomotive design that he summarized in the technical paper he presented to the Institution of Mechanical Engineers in 1893, with a single sentence that his colleagues found either visionary or absurd depending on their own experience. He wrote, and the words are still there in the institution's archive, "A locomotive built for the empire must be capable of being repaired by a man with ordinary tools in conditions of ordinary difficulty, and it must be capable of running in the intervals between those repairs for distances that would be considered extraordinary anywhere else." The locomotive he designed to embody this philosophy was a departure from everything conventional. The boiler was massive relative to the size of the locomotive, oversized by the standards of the day, and constructed with wall thicknesses that were considered wasteful by manufacturers more interested in minimizing material costs than in maximizing service life. Every access point to every mechanical component that might require attention in service was designed so that it could be reached without the specialized lifting equipment that existed in major workshops, but nowhere else. The valve gear, which in contemporary designs was a maze of precisely fitted components that required expert attention every few thousand miles, was simplified to a degree that Graig's colleagues considered almost primitive, reduced to elements that a moderately skilled fitter could adjust with hand tools and basic measuring equipment. The running gear was the most unconventional element of all. Graig specified bearing surfaces that were roughly twice the area of what contemporary practice called for, arguing that the extra material cost was trivially small compared to the operational cost of bearing failures in remote locations. He specified lubrication reservoirs that could sustain the locomotive for twice the normal service interval without attention, again at a material cost that accountants disliked, but that service experience in difficult territories consistently justified. He designed the entire mechanical structure with a philosophy that could be summarized as assume that anything that can go wrong will go wrong far from help, and build accordingly. The locomotive was completed at the North British Locomotive Company Works in Glasgow in 1897. It was built to a customer order for a railway company in Argentina that had been experiencing severe maintenance difficulties on a mountain line connecting the Andean foothills with the Pacific coast. The line was one of the most demanding in the world, combining extreme altitude changes with sharp curves, poor track maintenance, and water supply that contained mineral concentrations that destroyed conventional boiler tubes in months rather than years. The Argentine company wanted something that could survive those conditions for long enough to justify the cost of operating the line. Graig's locomotive was designated with the uninspiring nomenclature of its era as Works number 1147. It was painted in the Argentine company's livery of dark green with red and gold lining, loaded onto a ship at Glasgow docks in the autumn of 1897, and dispatched on the first leg of a journey that would ultimately take it to 4 continents over the next 60 years. The Andean service lasted 17 years, which was roughly 3 times longer than the company had expected when it purchased the locomotive. Works number 1147 climbed and descended, grades that defeated other engines, operated in temperatures that ranged from freezing mountain cold to scorching summer heat, and ran on water that would have scaled and destroyed a conventional boiler within months. The oversized bearing surfaces that Graig had specified proved their value immediately. Where other locomotives on the line required bearing attention every few thousand miles, 1147 ran clean and smooth for intervals that astonished the maintenance staff. The first declaration of death came in 1914, when the Argentine company, restructured under new ownership following a financial crisis, decided to rationalize its fleet. Works number 1147 was assessed by the company's new chief engineer, a Frenchman who had no experience of Graig's design philosophy and who looked at the locomotive's unconventional proportions and simplified valve gear with unconcealed skepticism. His written assessment concluded that the engine was obsolete, inefficient by modern standards, and unworthy of further investment. He recommended immediate withdrawal and sale for scrap. The locomotive was removed from service and placed in a siding at the company's maintenance facility in Mendoza. It sat there for 8 months while the paperwork for its disposal was processed, and during those 8 months a completely unrelated set of circumstances developed that would save it from destruction. The company discovered that its newer locomotives, purchased from European manufacturers at considerable expense, were performing significantly worse than expected on the mountain grades. The exotic valve gear and high-pressure boilers that had looked so impressive on paper were proving problematic in practice, requiring specialist attention that was difficult to obtain in Argentina. Works number 1147, sitting rusting in its siding, was quietly returned to service. It worked for another 6 years in Argentina before the second declaration of death, which came in 1920, when the company sold its entire locomotive fleet to a competitor, and the competitor's fleet manager, conducting his inventory of newly acquired assets, classified 1,147 as surplus to requirements. This time the locomotive was actually sold, purchased by a dealer in second-hand railway equipment who shipped it to South Africa, where the rapidly developing mining railways of the Witwatersrand were creating enormous demand for any working locomotive that could be bought cheaply and put to work immediately. In South Africa, Works number 1147 entered a chapter of its life that was harder than anything the Andean service had required. The mining railways of the Witwatersrand in the 1920s were operations conducted with ruthless efficiency and minimal sentiment. Locomotives were worked until they stopped working and then assessed for whether repair was cheaper than replacement. The oversized bearing surfaces and robust boiler construction that Graig had specified served the locomotive well here, but the conditions were severe enough that even 1147's exceptional construction was tested to its limits. The third declaration of death came in 1928, when a particularly hard service season left the locomotive with a cracked cylinder block, a condition that the mining company's engineer assessed as uneconomical to repair. The estimate for the repair was more than the locomotive's assessed residual value. The decision to scrap was entirely rational by any conventional accounting standard. Works number 1147 was moved to a siding once again, this time at a mining facility outside Johannesburg, and waited for the disposal process to complete. What saved it this time was a combination of bureaucratic delay and the arrival of a new workshop foreman who happened to have experience with the North British Locomotive Company's products from earlier in his career. He recognized the quality of the construction, understood that the cylinder crack was repairable by a competent engineer even if it was expensive, and made a personal case to the company's management that the locomotive was worth saving. The company, facing its own financial pressures, agreed only because the foreman offered to supervise the repair himself and personally guarantee the result. The cylinder was repaired. Works number 1147 returned to service. It worked in South Africa for another decade, through the Depression years when the mining companies were cutting costs to the bone, and every locomotive in the fleet was being squeezed for maximum output with minimum maintenance investment. The qualities that Graig had built into it sustained it through a period that eliminated dozens of less robust machines. By 1938, when it was sold again, this time as part of a fleet disposal that sent a collection of aging locomotives to railway operators across the British Empire. Works number 1147 had accumulated service mileage that would have been extraordinary for a locomotive half its age. The fourth declaration of death came in North Africa in 1942, when the locomotive, operating in support of military railway operations in Egypt, was caught in an air raid that damaged several vehicles in its consist and left 1,147 with shrapnel damage to the cab and tender and a bent running plate that looked catastrophic from a distance. The military railway officer who assessed the damage filed a report that recommended writing off the locomotive as beyond economic repair and concentrating available workshop capacity on less damaged units. The report was filed, the paperwork was processed, and works number 1147 was moved to a holding area for vehicles awaiting disposal. The repair that nobody was supposed to make happened anyway. Performed by a workshop crew that was operating under the inspired and slightly chaotic leadership of a South African sergeant mechanic who had spent years working on mining locomotives and who looked at the damage to 1147 and saw something very different from what the assessment report had described. The shrapnel damage was largely superficial. The bent running plate was structural but repairable. The locomotive's mechanical heart, that massively overbuilt running gear, and the robust boiler that Graig had designed to survive conditions worse than an air raid was essentially undamaged. The sergeant's crew repaired it in 3 days using field workshop equipment and returned it to service without filing any paperwork that might have triggered an inquiry into why they were repairing something that had been officially written off. The fifth declaration of death came after the war, in 1947. When works number 1147, by now extraordinarily old and extraordinarily well-traveled, found itself in a post-war railway system that was comprehensively reorganizing its motive power and had very little patience for locomotives that didn't fit neatly into the standardized fleet categories that post-war management preferred. A fleet audit conducted by British railway consultants brought in to advise on modernization identified 1147 as a non-standard type with no spare parts support and no remaining manufacturer relationship. The recommendation was disposal. The locomotive was removed from service for the 5th time and placed in storage. What followed was the longest period of inactivity in the locomotive's history, 5 years during which it sat in an equipment compound in Kenya, where it had been working on an agricultural railway, gradually acquiring the surface rust and accumulated grime that made it look, to any casual observer, exactly like what the audit report had classified it as, a dead machine waiting for formal confirmation of its death. The confirmation never came, because in 1952, a newly appointed engineer in the Colonial Railway Administration discovered the locomotive during an inspection tour, recognized from the works plate still attached to the cab that it was a North British product of the 1890s, and became curious enough about its history to make inquiries that eventually led him to the original design specifications. What he found in those specifications was exactly what Graig had intended anyone who found them to find: a clear and detailed case for why this locomotive, however old and however unconventional, was worth keeping. The oversized bearing surfaces were barely worn. The boiler, despite decades of service, was structurally sound. The simplified valve gear was in excellent condition. Works number 1147 was returned to service for the fourth time and worked reliably for 3 more years before being transferred to Australia as part of a fleet sale. In Australia, it found its 6th and final declaration of death in 1958, when the Agricultural Railway in New South Wales that had purchased it decided to convert entirely to diesel traction and assessed its steam fleet for disposal. Works. Number 1147 was among the locomotives placed in an outdoor storage facility on the edge of the Riverina Plain, where it spent 3 years absorbing the particular combination of sun, dust, and occasional flooding that Australian plains weather delivers to anything left unprotected in the open. By the time a Preservation Society found it in 1961, the locomotive had been sitting in the open for 3 years and looked, to eyes unfamiliar with its history, exactly like what it appeared to be. A very old, very tired machine that had been left to die quietly in the Australian sun. The preservationists almost passed it over in favor of younger and more accessible locomotives that seemed like better candidates for restoration. What stopped them was the works plate. One of the society members knew enough about North British Locomotive Company products to recognize that the plate indicated something unusual, a locomotive of a type and age that should not, by any reasonable calculation, have been capable of reaching Australia in operational condition. The inquiry that followed eventually reconstructed enough of the locomotive's history to make its survival seem not just remarkable, but essentially impossible. A locomotive built in 1897 that had worked in Argentina, South Africa, Egypt, East Africa, and Australia, that had been officially declared dead 6 times and returned to service every time, was not an ordinary machine. It was something that deserved to be understood. The restoration was completed in 1967, 70 years after the locomotive left the Glasgow works, where Graig had translated his hard-won operational philosophy into steel and copper. Works. Number 1147, repainted in its original Argentine livery, ran on heritage railways in New South Wales for another decade before being placed on permanent display. It stands there today, and if you look at it carefully, if you understand what you are looking at, you can see in every oversized bearing surface and every simplified valve assembly and every heavy boiler plate the expression of a philosophy that Graig had paid for with 15 years of difficult service in conditions that destroyed ordinary machines and taught him, slowly and expensively, what durability actually required. He never knew what his locomotive survived. He died in 1921. Just as works number 1147 was completing its South African service, and before it had faced the air raid, the equatorial storage, or the Australian sun. He never knew that his paper to the Institution of Mechanical Engineers, which had been received with polite skepticism by colleagues who considered his weight specifications wasteful and his design simplifications retrograde, had been validated not in test conditions or on controlled trials, but in the most demanding proving ground imaginable. 6 decades of service across 4 continents, 6 official declarations of its own death, and a survival that can only be explained by going back to those 1,893 design specifications and reading again the sentence that contained the entire philosophy. A locomotive built for the Empire must be capable of being repaired by a man with ordinary tools in conditions of ordinary difficulty, and it must be capable of running in the intervals between those repairs for distances that would be considered extraordinary anywhere else. Graig wrote that sentence, and then he built the locomotive that proved it. And the locomotive ran, and was declared dead, and ran again, across Argentina and South Africa and Egypt and Kenya and Australia, until there was nobody left alive who remembered the man who had designed it, or the philosophy that had made its survival possible. The machine outlasted the empire it was built for. It outlasted the technology that replaced it. It outlasted the men who built it, the men who operated it, the men who declared it dead, and the men who proved those declarations wrong. It outlasted everything except the willingness of a small group of people in New South Wales who understood that a machine with a history like that deserved something better than the cutting torch that had taken so many of its contemporaries. There is a lesson in works number 1147, though it is a lesson that the railway industry of its era largely failed to learn. The lesson is that the qualities that make a machine durable are not the qualities that make it look impressive in a manufacturer's catalogue. Oversized bearings are not glamorous. Simplified valve gear does not win prizes at engineering exhibitions. Heavy boilerplates add weight that accountants dislike. Every quality that allowed this locomotive to survive 6 official deaths and 60 years of service across 4 continents was a quality that conventional engineering practice of its era considered unnecessary, excessive, or simply wrong. Graig was not wrong. He was building for a world that would test his machines in ways that no laboratory could simulate, in conditions that no specification could fully anticipate, over distances and durations that made a mockery of the conservative service assumptions that underpinned mainstream locomotive design. He built for that world because he had lived in it, because he understood from personal experience what it demanded, and because he refused to let the comfortable conventions of a Glasgow drawing office override the hard knowledge that fieldwork had given him. The locomotive that crossed 3 continents and was declared dead 6 times is not famous. Its name is a works number on a plate. Its designer is not remembered except by specialists who have read his 1893 paper and traced its implications through the operational history of a single machine. But the machine itself, standing in its display case in New South Wales, carries more engineering truth in its oversized bearings and its simplified valve gear than most celebrated locomotives carry in their entire mechanical systems. It was built to survive. It was built by a man who understood survival, and it survived over and over and over again, until surviving became the most remarkable thing a locomotive had ever done. Works number 1147, built Glasgow, 1897, declared dead 6 times, still standing. That is the only obituary it needs.